Hello there, and welcome to Sleepy Science Vault. Settle in. Take a slow breath. And let your body relax. Tonight, we are going to drift together toward the edge of everything. Or at least, toward what we think is the edge. Because here is where it gets interesting. Here is where the universe does something quietly remarkable. When you ask the question, where does the universe end? The answer is not what most people expect. There is no wall out there. No fence. No great barrier where space suddenly stops. The universe does not end the way a room ends. It does not end the way an ocean ends at a shoreline. What we call the edge is something far more subtle, far more beautiful. It is a horizon, much like the horizon you see on a clear day. When you stand at the shore and look out across the water, that line in the distance is not where the world ends. It is simply as far as your eyes can reach. And the edge of the universe works the same way. We call it the cosmic horizon. And it is not a place where space stops. It is a place where light runs out of time to reach us. Let that settle for a moment. The light we see in the night sky has been traveling for millions, billions of years to finally arrive at your eyes. But some light started its journey so far away, in a universe that has been stretching and expanding, that it will simply never reach us. Not because anything is blocking it, but because the universe is growing faster than the light can travel. So the horizon we talk about is not a wall in space. It is a wall in time. A limit on information. A quiet boundary beyond which the universe holds its secrets. Think of it this way. Everything we have ever seen, every star, every galaxy, every faint smudge of light in the deepest telescope images, all of it sits inside a region we call the observable universe. This is the part of existence that has had a chance to speak to us. The part whose light, whose signals, whose ancient whispers have had enough time to cross the vast distances of space and arrive here, at this small, quiet planet. But the observable universe is not the whole universe. It is only the part we can detect, the part that has been able to reach us. And here is something truly worth sitting with tonight. Scientists believe that beyond our horizon, beyond the edge of what we can ever see, the universe almost certainly continues. More stars, more galaxies, more space, stretching outward in all directions, perhaps for a distance so great that no number we know of could describe it. And some of the most careful, thoughtful minds who have ever studied the cosmos believe the universe may not just be very large. They believe it may be infinite, with no end, in any direction, ever. If that is true, then our cosmic horizon is not the edge of everything. It is simply the edge of our view. Like standing in a vast, dark forest at night, with only a single lantern. You can see the trees within your little circle of light. But the forest goes on, and on, and on, far beyond where your light can reach. the darkness beyond is not emptiness. It is just beyond your glow. So when you think of the edge of the universe tonight, let go of the image of a wall, or a fence, or a final frontier where something ends. Instead, imagine a soft horizon, like the kind you see just before dawn breaks. A gentle limit. Not the end of the world, but simply the end of what this moment allows you to see. The universe is under no obligation to fit inside our view. And somehow, that is one of the most peaceful thoughts there is. We are here, in the middle of something incomprehensibly vast. Something that may have no edges at all. Something that was here long before us, and will continue long after. Let your eyes grow heavy. Let your breathing slow. The universe is far larger than we can imagine, and you are resting gently inside it. And so we drift a little deeper into the quiet, into the vast, patient dark. We have already learned that the edge of the universe is not a wall. It is a horizon, a soft limit on what we can see. But now a gentle question arises. Why does that horizon exist at all? Why can we only see so far? The answer begins with something very simple. Something almost tender in its honesty. The universe has an age. Our cosmos is approximately 13.8 billion years old. 13.8 billion years. Since the very first moment of everything. Since the universe drew its first breath. And in all that time, light has been traveling, racing outward in every direction, at the only speed it knows, the fastest speed anything in the universe can move. About 300,000 kilometers every single second. That is almost impossible to imagine. So just let it wash over you. 300,000 kilometers. In 1 second. In the time it takes you to breathe in and breathe out again. A single beam of light travels a distance so immense that it would circle our entire planet more than 7 times. And yet, even at that extraordinary speed, light can only have traveled so far. In 13.8 billion years. That distance, that reach, is what defines our horizon. Not a wall placed there by anything. Not a boundary drawn by any law. Simply the quiet, mathematical consequence of a universe with a beginning and light with a speed. The cosmic horizon is really a time limit. More than a distance. It marks how far light has had time to travel. Since the very first moment of the universe. Think of it like ripples on a still pond. When you drop a stone into calm water, the ripples spread outward, growing, expanding, reaching further with every passing second. But no matter how long you wait, those ripples can only have traveled as far as the time allows. Light is like those ripples, spreading outward from the moment of the Big Bang. And our horizon is simply the outermost edge of that expanding ring. The farthest ripple that has had enough time to reach us. But here is something quietly wonderful. The horizon is not fixed. It is not a permanent line drawn once and left forever. Because time keeps passing. The universe keeps evolving. And more distant light keeps arriving. Every moment that goes by, the observable universe grows, ever so slightly, larger. New regions of the cosmos, that were once beyond our reach, creep slowly into view. As their ancient light, finally, arrives. You could think of it as the universe slowly revealing itself to us. Like a long, patient letter being delivered, written billions of years ago, and still arriving, line by line, word by word. The observable universe is not a fixed bubble, frozen in place. It is a living, growing window that expands with time and will continue to expand long after any of us are here to watch. Now there is something else worth resting your mind on. Something a little dreamlike. When we look out toward the horizon, when our telescopes peer into the farthest reaches of what we can detect, we are not seeing the universe as it is. We are seeing the universe as it was. The light reaching us from the most distant galaxies left those galaxies billions of years ago. Those galaxies were young then. The universe was young then. Barely formed. Still finding its shape. By the time that light has crossed the immensity of space and arrived at our telescopes, those galaxies have changed completely. They have aged, evolved. Some may no longer exist at all in their original form. So the edge of our observable universe is not just a place. It is a time. A window into the deep, ancient past of the cosmos. Looking at the horizon of the universe is like holding a photograph from billions of years ago, and knowing that the people in that photograph are unrecognizably different now, or perhaps gone entirely. We are looking at the universe's earliest memories, preserved in light, carried across impossible distances, and delivered to us, here, tonight. And as the universe continues to expand, as time continues its patient, unstoppable flow, the horizon continues to shift. The set of things we can observe changes. Some objects we can see today may one day drift beyond our reach, carried away by the expansion of space itself, while other regions, not yet visible, will slowly come into view. It is a horizon that breathes, that moves, that evolves alongside everything else. We are not looking at a static picture. We are watching a slow, ancient process. A cosmic story. Still unfolding. Still being written. With light as its ink. And time as its page. So as you rest here, in this quiet moment, know that the universe is doing what it has always done. Expanding. Revealing. Sending its old light toward you. Across distances that words can barely hold. And somewhere out there, beyond the farthest thing we have ever seen, beyond the oldest light we have ever caught, the universe continues. patient, vast, and completely unhurried. Just like you can be right now. Let your thoughts slow. Let your breathing deepen. The horizon exists because the universe has an age. And because it has an age, it has a story. And the light reaching us tonight is the oldest, most beautiful chapter of that story. Arriving, at last. Just for us. Rest now. There is no rush. The universe has been here for nearly 14 billion years. It will wait for you. And still, we drift a little further. A little slower. A little deeper into the quiet. We have learned that our horizon is a limit set by time. That the universe has an age. And that light can only travel so far. In 13.8 billion years. But now, something remarkable. Something that takes a moment to truly settle in. When we look toward that horizon. Toward the very edge of what our telescopes can reach. We are not just looking far away. We are looking far back. The objects we see near the edge of our observable universe are not old objects seen in their current state. They are young objects, seen as they were in the earliest chapters of cosmic history. Their light has been traveling for so long that by the time it reaches us, it carries the image of a universe that barely existed yet. A universe still in its infancy. Still taking shape. Still figuring out what it would become. And as that light travels, something happens to it. Something gentle and inevitable. The universe is expanding. And as it expands, the space between us and those distant objects stretches. And as that space stretches, the light traveling through it stretches too. Its wavelength grows longer. Its color shifts. It moves from the bright blues and whites of young, energetic light, slowly, toward the red, toward the infrared, toward wavelengths our eyes cannot even see. This is called redshift. And the farther away an object is, the more its light is stretched during the journey, the higher its redshift. So the edge of our observable universe is also a frontier of extreme redshift. A place where light arrives so stretched, so ancient, so transformed by its long journey, that we need special instruments just to detect it at all. It is as if the universe's oldest light arrives at our door, tired from the journey, changed by the distance, whispering instead of speaking. And we lean in close and listen. Now, here is where something truly mind-bending begins. Something that gently, beautifully, defies intuition. You might assume that if light has been traveling for 13.8 billion years, then the edge of our observable universe must be 13.8 billion light years away. A light year for every year of the universe's age. It seems so clean, so logical. But the universe does not do clean and logical. Not in the way we expect. The observable universe is actually much larger. then 13.8 billion light-years across. The current radius of the observable universe is approximately 45 billion light-years, which means the full observable universe, from one side to the other, spans roughly 92 to 93 billion light-years. Let that number rest in your mind for a moment. 93 billion light-years. How can this be? If light has only had 13.8 billion years to travel, how can it have reached us from 45 billion light-years away? The answer is something extraordinary. Space itself was expanding while the light was traveling. Imagine placing an ant on one end of a rubber band and slowly stretching the rubber band as the ant walks. The ant is moving, but the surface it is walking on is also growing. So by the time the ant reaches the other end, the rubber band is far longer than when the journey began. Light is like that ant, and space is like that rubber band. The light left its source billions of years ago, but space has been stretching the whole time. So the source of that light is now much farther away than it was when the light departed. By the time the light arrives at our telescopes, the object that sent it has been carried far beyond where the light originated by the quiet, relentless expansion of space. So when we look toward our cosmic horizon, we are seeing light that left its source when that source was much closer to us. But that source has since been carried outward to a distance of about 45 billion light-years. The universe grew around the traveling light, and the light arrived anyway, patient and faithful, carrying its ancient image across a distance that kept changing beneath its feet. 93 billion light-years across, a sphere of everything we can detect, everything that has had a chance to speak to us. And this sphere is perfectly centered on us. Not because Earth is special, not because we are at the center of the universe, but because the observable universe is defined by perspective. Any observer anywhere in the cosmos would see themselves at the center of their own observable universe. Each one a sphere, each one unique to that observer's position, each one a different window into the same vast reality. From a galaxy a billion light-years away, there is another observer, perhaps, looking out at their own sphere of everything they can see, and their horizon is different from ours. Their ancient light comes from different directions. Their cosmic story has different chapters visible to them. We each carry our own observable universe with us, defined by where we are and how long the cosmos has been speaking. The universe is not a room with a single center. It is more like an infinite ocean, where every point on the surface is the center of its own horizon. Every swimmer sees a different circle of water around them, but the ocean is the same ocean, vast, undivided, belonging to no single point. And yet here we are, on this small, quiet world, at the center of our own private window into everything. 93 billion light-years of observable space, arranged like a sphere around our little blue planet. Not because we are special, but because we are here. Because we are the ones who are looking. And tonight, you are one of the ones looking. Or perhaps, just listening. As the universe whispers its measurements, its distances, its impossible numbers, softly into the dark. 93 billion light-years. 45 billion to the horizon in any direction. Ancient light, stretched red by its journey, arriving transformed, but still arriving. Let the size of it wash over you, not with overwhelm, but with wonder. The quiet kind of wonder, the kind that makes your shoulders drop, and your breath slow, and your body feel somehow lighter. You are resting inside the most remarkable structure that we know of anywhere in existence. A universe so large that its true size may never be fully known. And the part we can see is already beyond all imagining. So let your eyes grow heavy. Let the numbers dissolve into feeling. 93 billion light-years. And you, small and warm and breathing, right at the center of your own quiet corner of it all. Rest here. The universe is in no hurry, and neither are you. And so we continue. Gently. No rush. Just the soft unfolding of one idea into the next. Like a tide coming in. Slow and certain. We have been sitting with the size of the observable universe. 93 billion light-years across. A sphere of everything that has ever had a chance to reach us. Centered quietly on us. But that word, centered, deserves a moment of its own. Because it can feel strange. Even a little uncomfortable. To hear that the observable universe is centered on Earth. It can sound like an old, discarded idea. Like the ancient belief that we sat at the middle of everything. The sun revolving around us. The stars pinned to a dome above our heads. But this is something beautifully different. The observable universe is centered on us. Not because we are special. Not because the cosmos arranged itself around our planet. But simply because we are the ones doing the observing. The observable universe is not a place. It is a perspective. Think of it like standing in a field on a foggy night. The fog clears in a circle around you, stretching equally in every direction, as far as the visibility allows. You are at the center of that clear circle. But not because the field was built around you. Simply because you are the one standing there. If someone else stood a mile away, they would have their own circle of clarity, centered on them, overlapping with yours, but not identical. Their view would reach different trees, different hills, different edges of the same foggy world. And so it is with the universe. Every observer, anywhere in the cosmos, sees themselves at the center of their own observable universe. Their own sphere of everything that light has had time to deliver to them. A being in a galaxy 100 million light years away looks out and sees a different sphere, different ancient light, different distant structures, a different window into the same infinite reality. There is no single universal edge, no one horizon that everyone shares. The horizon belongs to the observer. It travels with them. It is as personal as a shadow. And here is something even quieter, even more worth sitting with in the dark. The universe may have no center at all. Not a hidden center. Not a center we cannot find. But genuinely, no center. In a universe that is infinite, or even in one that is finite but has no boundary, the concept of a center simply does not apply. Every point is equally valid. Every location is as central as any other. The universe does not have a middle, any more than the surface of a sphere has a middle. You can walk in any direction on a sphere forever and never reach an edge and never reach a center. We are not at the center of the universe. We are simply here, and here is enough. Here is where the light arrives. Here is where the questions are asked. Here is where you are resting tonight. Let that land softly. Now, we have been looking outward, toward the horizon, toward the farthest reaches of what we can observe. But there is a question that arises, a natural one. What if we built a better telescope? What if we made our instruments more powerful, more sensitive, more precise? Could we push past the horizon? Could we see beyond? And the answer is quietly, profoundly, no. Not because our technology is lacking. Not because we have not tried hard enough. But because the horizon is not a problem of instruments. It is a problem of time. No telescope, however powerful, however perfectly constructed, can see light that has not yet arrived. And light from beyond our horizon simply has not had enough time to reach us. The universe has been around for 13.8 billion years. That is the limit. That is the ceiling. And no lens we grind, no mirror we polish, no detector we build, can add a single year to the age of the cosmos. The horizon is baked into the nature of things. It is not an engineering challenge. It is a feature of reality itself. But even within our horizon, there is a limit, an earlier wall, a place where even our best telescopes fall silent, because the universe was not always transparent. In the very beginning, in the first hundreds of thousands of years after the Big Bang, the universe was a place of extraordinary, almost unimaginable heat and density. Matter and light were tangled together, not yet separate, not yet free. The universe was filled with a blazing, opaque plasma, a fog so thick, so complete, that light could not travel through it at all. Light would start to move, and almost immediately collide with something, scatter, and lose its way. The universe was closed to light, impenetrable, a place where vision simply did not exist. And then, after about 380,000 years, something changed. The universe had expanded enough, cooled enough, that matter began to settle. Electrons found their way to protons. Atoms formed for the first time. And suddenly, the fog lifted. Light was free. For the very first time in cosmic history, light could travel, unimpeded, across space. And that light, that first free light, that ancient release, is still traveling today. We call it the cosmic microwave background. And it is one of the most remarkable things humanity has ever detected. It is the afterglow of that moment, when the universe first became transparent. A faint, gentle, almost undetectable warmth, reaching us from every direction equally. A whisper from 380,000 years after the beginning. When we map this ancient light, we are looking at the oldest signal we can ever receive through ordinary means. A photograph of the universe in its earliest visible moment. Still in its infancy. Still glowing from the heat of its own birth. Before that moment, there is a wall of opacity. A cosmic curtain we cannot see behind. Not with any telescope. Not with any technology we can imagine. The early universe is hidden from us. Not by distance, but by its own ancient density. We can study what came before through other means. Through gravitational waves. Through the mathematics of physics. Through careful inference and theory. But in terms of light, in terms of what our eyes and telescopes can see, the cosmic microwave background is the beginning. The earliest page of the visible universe. And it is everywhere. Right now. Surrounding you. Passing through the walls of wherever you are resting. Ancient light from nearly 14 billion years ago. Flowing through the universe. Flowing through you. As quietly and constantly as breathing. The first light. Still traveling. Still arriving. After all this time. Let that settle into you like warmth. We are not separate from this story. We are inside it. Bathed in the oldest light that can reach us. Living within the observable universe that surrounds us equally in every direction. Sitting at the center of our own private window into eternity. And around us, other windows. Belonging to other observers. Stretching across a cosmos that may have no center. And no edge. And no end. Just the quiet, patient, endless unfolding of everything. Rest now. Breathe slowly. The universe has no single edge that belongs to everyone. And it has no center that belongs to anyone. It simply is. All of it. Everywhere. All at once. And you are part of it. Resting here. In the dark. Held gently by a universe that has been expanding. since long before you arrived, and will continue expanding long after tonight. Let your thoughts grow soft. Let the ancient light pass through you. Let the fog of the early universe and the freedom of that first clear moment carry you slowly towards sleep. And still we drift further into the quiet, further into the dark. Let your body sink a little deeper into wherever you are resting. Let your shoulders fall. Let your hands relax. We have been traveling together through the story of the observable universe, through its size, its horizons, its ancient light. And we arrived, just a moment ago, at one of the most extraordinary signals in all of science: the cosmic microwave background. That faint, ancient warmth, the first light ever to travel freely through the universe. Tonight, let us sit with it a little longer. The cosmic microwave background was released approximately 380,000 years after the Big Bang. 380,000 years sounds like a long time, and in human terms, it is nearly incomprehensible. But in the life of a universe, it is the very first breath, the very first exhale. The universe had barely begun, and yet already it had cooled just enough, settled just enough, for light to be set free. Before that moment, every photon of light that tried to travel was almost immediately absorbed or scattered. The universe was like a room so full of smoke that you could not see your own hand in front of your face. And then the smoke cleared. Electrons and protons came together to form atoms. And suddenly, the universe became transparent. For the first time, light had somewhere to go. That release, that moment of clearing, is what scientists call the last scattering surface. It is the moment when light last touched matter, before beginning its long, uninterrupted journey across the cosmos. And that surface, that ancient shell of first light, is what we detect today as the cosmic microwave background. It is not a physical wall, not a solid thing you could touch or approach. It is more like a moment, frozen in light, a thin, glowing boundary to what we can ever observe, the earliest horizon within our horizon. And it is all around us, equally, in every direction, a perfect sphere of ancient signal, surrounding our little planet, surrounding our solar system, surrounding everything we have ever known. When you look in any direction, at the very deepest limit of what any instrument can detect, you eventually reach the surface, this veil of first light. Beyond it, the universe is hidden, wrapped in the memory of its own early heat. And that surface, that glowing boundary from 380,000 years after the beginning, is now almost incomprehensibly far away, because space has been expanding ever since that light was released. The region of the universe where the cosmic microwave background originated has been carried outward, stretched by the growth of space itself, to a distance of about 45 billion light-years. The light was emitted when that region was much closer, but space grew around it. And now the source of the oldest light we can see sits at the very edge of our observable universe, carried there not by any motion, but by the quiet, patient expansion of space itself. Which brings us to something that takes a little while to settle into. But once it does, it changes how you see everything. When we say the universe is expanding, it is easy to imagine it like an explosion. Matter flying outward through empty space. Galaxies rushing away from a central point, like sparks from a fire. But that image, as natural as it feels, is not quite right. The universe is not expanding into anything. There is no surrounding emptiness waiting to receive it. No container being filled. Instead, space itself is expanding. Everywhere. All at once. It is not that galaxies are moving through space. It is that the space between galaxies is growing, stretching, like dots drawn on the surface of a balloon being slowly inflated. The dots themselves do not move across the balloon. The balloon grows, and the dots find themselves further apart, not because they traveled, but because the surface between them expanded. This is one of the most quietly revolutionary ideas in all of human understanding. Space itself is not a fixed stage on which things move. Space is a dynamic, living, growing thing. It stretches. It expands. It carries galaxies apart from one another. Not through any force they feel, not through any journey they take, but simply because the fabric they rest in is getting larger. And this expansion has a remarkable consequence. The further away a galaxy is, the more space there is between us and it. And the more space there is, the faster that space is expanding between us. For very distant galaxies, the space between us and them is expanding so rapidly that those galaxies are receding from us faster than light. Now, this might sound like it breaks the rules, like something impossible, like a violation of everything physics holds dear. But it does not break the rule that says nothing can travel through space faster than light. Because these galaxies are not traveling through space. Space itself is carrying them. And space has no speed limit. It can expand as fast as it likes. It is a distinction that feels almost like a riddle. But it is real. And it means that right now, as you rest here, there are galaxies beyond our horizon. Being carried away from us faster than light can bridge the gap. Galaxies that were once closer, that perhaps briefly fell within our observable window, but have since been swept beyond our reach, never to be seen again. Not because they moved, but because space moved between us and them. And this brings us to something called the Hubble radius, named for the astronomer Edwin Hubble. who first measured the expansion of the universe and changed our understanding of the cosmos forever. The Hubble radius marks the distance at which galaxies are receding from us at exactly the speed of light. Due to cosmic expansion inside the Hubble radius, galaxies recede from us slower than light. Their light can still reach us. We can still observe them. Beyond the Hubble radius, galaxies are being carried away faster than light. But, and this is the subtle part, they can still sometimes send us light, because the Hubble radius is not the same as the edge of the observable universe. Space between here and those distant galaxies is also expanding, and sometimes light emitted from beyond the Hubble radius enters a region of slower expansion and manages to crawl toward us, and eventually arrives. The Hubble radius and the cosmic horizon are different boundaries, measuring different things, like two different fog lines in the same landscape, one marking where the expansion becomes faster than light, one marking where information simply runs out. The universe is full of these nested horizons, these layered limits, each one telling a different part of the story. And all of it, every boundary, every horizon, every receding galaxy, is the result of one quiet, continuous process. The expansion of space itself, happening everywhere, at every moment, including this one, right now. As you breathe slowly, as your thoughts grow soft and distant, the space between galaxies is growing. Galaxies that were already unimaginably far away are becoming more unimaginably far away by the second. In the cosmic microwave background, that ancient veil of first light sits at the edge of it all. The farthest thing we can see, the oldest signal we can receive, surrounding everything, in every direction. A reminder that the universe has been on a long journey, and we are part of it, somewhere near the middle of its story, or perhaps much nearer to the beginning than we will ever know. Let the expansion of space carry your thoughts outward, gently, slowly, like a tide going out. Let the image of that ancient glowing surface, that wall of first light at the edge of everything we can see, rest behind your eyes like a soft glow. The universe is growing, even now, and you are resting, held safely inside it, while it expands around you, in every direction, without hurry, without end. Sleep is not far now. Let it come, as naturally as space expands, as gently as ancient light arrives. You are safe here, inside the universe, inside the quiet, inside the dark. Rest, and we continue, softly. No hurry at all. Let the quiet settle around you like something warm, like the feeling just before sleep arrives, when thoughts begin to slow, and the edges of things grow soft. We have been exploring the expansion of the universe, the way space itself grows, carrying galaxies apart from one another, not through motion, but through the gentle, relentless stretching of the fabric between them. And now, from that idea, something quietly melancholy arises. Something worth sitting with. Not with sadness, but with a kind of peaceful wonder. Some of the galaxies we can see tonight will one day disappear. Not destroyed. Not gone in any violent sense. Simply carried away. Beyond our reach. Beyond our horizon. Into a distance so vast that their light will never find us again. Right now, there are galaxies visible in our deepest telescope images. Ancient, distant, beautiful. Billions of light years away. Still within our observable window. Still speaking to us in the language of ancient light. But the expansion of space is relentless. And for some of these galaxies, the space between us and them is growing faster than any future light they send could ever cross. One by one, slowly, over billions of years, they will slip beyond our future horizon. Their light will grow fainter, more redshifted, more stretched, until one day, their last photon reaches us. And then, silence. They will still exist. Out there, somewhere in the universe, full of stars, perhaps full of worlds, perhaps full of life looking back toward us, facing the same slow disappearance. But we will no longer be able to see them. And they will no longer be able to see us. Not because anything was destroyed, but because the universe grew too large for the connection to survive. There is something achingly beautiful about that. Entire galaxies, drifting beyond the reach of light. Not lost, just unreachable. Like a letter sent to an address that no longer exists. The letter travels faithfully, but the destination has moved beyond finding, and beyond our current horizon, beyond even the farthest galaxies we can detect today. There are almost certainly more, countless galaxies whose light simply has not arrived yet. Not because they are not there, but because the universe has not given their light enough time to cross the distance between us. They exist in the dark beyond our window, patient, unknown, sending light toward us even now. Light that will not arrive for billions of years. Or perhaps will never arrive at all, depending on how the expansion unfolds. The universe beyond our horizon is not empty. It is simply waiting. Or perhaps it is not waiting at all. It's simply indifferent to whether we can see it, going about the business of existing without us. Let that image rest in your mind. An infinite dark beyond the horizon, filled with light we cannot catch, with galaxies we cannot name, with distances that make our observable universe feel almost intimate. And now, let us drift back, further back than the cosmic microwave background, further back than the first free light, to the very first moment, the very first fraction of a second. Because something happened then, something almost beyond imagining, something that shaped everything we see, and everything we cannot see. In the universe's first extraordinary instant, scientists believe that space underwent a period of expansion so rapid, so violent in its speed, that it makes all the expansion since seem almost leisurely. This period is called inflation. In an almost incomprehensibly brief sliver of time, far shorter than any clock could measure, space expanded by a factor so enormous that tiny regions, smaller than a single atom, were stretched to sizes larger than entire galaxies. Everything was flung outward. Distances grew by factors that make ordinary numbers feel meaningless. The universe went from something almost inconceivably small to something vast. In a moment so brief, it barely qualifies as a moment at all. And this extraordinary early expansion is part of why the observable universe is as large as it is. Part of why 45 billion light-years of space lies within our view. Even though the universe is only 13.8 billion years old. Inflation stretched everything. Rapidly. Uniformly. In all directions. Which brings us to something that has puzzled and delighted scientists for as long as they have had the tools to notice it. The universe looks remarkably the same in every direction. When we map the cosmic microwave background, that ancient surface of first light, we find that its temperature is almost identical, no matter which way we point our instruments, left or right, up or down. In any direction we choose to look, the temperature of that ancient signal varies by only the tiniest fractions, barely 100,000th of a degree, across the entire sky. The universe is uniform. Strikingly, almost eerily, uniform. At the largest scales we can observe, it looks essentially the same everywhere. Now this might seem expected, but think about what it actually means. Regions on opposite sides of our observable universe. Regions so far apart that no signal, no light, no information of any kind could ever have passed between them. Not even in the entire age of the universe. Those regions have the same temperature, the same density, the same fundamental properties. How could things that have never been in contact, never been able to communicate, never shared even a single photon, end up so similar? This is one of the great puzzles of cosmology. And inflation offers the most compelling answer we have. Before inflation, before that extraordinary burst of expansion, everything was close. Everything was in contact. Everything had time to reach the same temperature, the same equilibrium, the same settled state. And then, Inflation stretched it all apart, rapidly, carrying those once connected regions to opposite ends of the observable universe. Too fast for any subsequent signal to bridge the gap, but carrying with them the memory of their early connection, their shared temperature, their common origin. The uniformity we see today is the echo of a connection that existed before our observable universe was even as large as a single grain of sand. It is like twins separated at birth, raised in different countries, different cultures, different worlds, and yet, somehow, sharing the same laugh, the same gesture, the same quiet way of tilting their head. Because they came from the same beginning. The universe carries its origin and its temperature across distances that should have made similarity impossible. And yet, it is not perfectly uniform. There are tiny variations, small ripples in the temperature of that ancient light. Regions slightly warmer, regions slightly cooler, by amounts so small they are almost beyond detection. But those tiny variations, those whisper-thin differences in the early universe, are where everything interesting came from. Those tiny ripples were the seeds of everything that would follow. Galaxies, clusters of galaxies, the great cosmic web of structure that fills the universe today. The early universe was almost perfectly smooth, but not quite. And that almost, that tiny deviation from perfect uniformity, is the reason stars exist, the reason galaxies exist, the reason worlds exist, the reason you exist. A universe of perfect uniformity would have no stars, no galaxies, no planets, no life. But the universe was not quite perfect. It had tiny imperfections. And from those imperfections, gravity slowly, patiently, over billions of years, sculpted everything. The universe's slight imperfection is the gift that made everything possible. Let that settle into you now. You are here, in this quiet moment, because the early universe was almost, but not quite, perfectly smooth. Because inflation stretched those tiny quantum ripples to cosmic scales. Because gravity gathered those ripples into stars, and stars into galaxies, and galaxies into the universe you rest within tonight. A chain of events stretching back to a fraction of a second after the beginning, leading through billions of years of cosmic evolution to this, to you, breathing slowly, eyes heavy, resting inside the universe that made you. The cosmos was almost uniform, but not quite. And because of that, here you are. Let your breathing slow. Let your thoughts grow soft as that ancient temperature. Nearly constant. Nearly still. The universe stretched itself to enormous sizes in its very first moment, and has been expanding gently ever since. And you, in the middle of all that expansion, in the center of your own quiet horizon, are drifting now, slowly, towards sleep. The galaxies are receding. The ancient light is traveling. The universe is growing. And you are resting. Perfectly. Exactly where you are. And still we drift. Deeper. Quieter. There is no need to hold on to anything tonight. No need to follow every thought to its end. Just let the words arrive and pass through you, like the ancient light we have been speaking of, traveling gently, without effort, without urgency. We have been sitting with the early universe, with its almost perfect smoothness, with the tiny ripples that became everything, and that smoothness, that extraordinary uniformity of temperature, tells us something else. Something about the shape of the universe itself. Because when scientists measure the geometry of space, when they ask not just how large the universe is, but what shape it has, they find something quietly remarkable. Space, on the largest scales we can measure, appears to be flat. Now, flat does not mean two-dimensional. It does not mean the universe is a great plane stretching outward. In the language of cosmology, flat means something more subtle, more mathematical. It means that the rules of geometry we learned as children, the geometry of straight lines and parallel paths, the geometry where the angles of a triangle always add up to 180 degrees, hold true across the cosmos, at the largest scales we can observe. Space does not appear to curve back on itself, or curve away into infinite openness. It lies flat, like the surface of a calm, still sea, stretching outward in all directions, without bending. But what does that mean for the shape of the whole universe? Here's where we must be honest about what we do not know. And there is something peaceful in that honesty. Something restful about sitting at the edge of human knowledge and simply looking out. One possibility is that the universe is closed, finite, curved gently back on itself, like the surface of a sphere, but in 3 dimensions. In such a universe, if you could travel in a perfectly straight line for long enough, you would eventually return to where you started. The universe would be like the surface of a bubble. No edge, no center, but not infinite either. Bounded but boundless. Finite but without a border. It is a shape our minds reach for and cannot quite hold. Another possibility is that the universe stretches on forever, infinite in every direction, flat, without end, containing an infinite number of galaxies, an infinite number of stars, an infinite number of worlds, in an infinite universe. Everything that can happen does happen somewhere, infinitely many times. There may be another version of this moment, infinitely far away, Another quiet room. Another voice. Another set of ears listening to these same words. In a universe so large, that repetition becomes inevitable. And some estimates suggest that even if the universe is not infinite, it may be larger than our observable portion, by factors so enormous they dissolve into meaninglessness. Our observable universe, those 93 billion light-years of detectable space, may be a tiny fraction of the whole, a bubble within a vastness so much greater that comparing the two is like comparing a single grain of sand to all the beaches of Earth, and then realizing even that comparison falls short. We genuinely do not know, and that is all right. There is a kind of relief in not knowing, in reaching the edge of what human minds have managed to measure, and finding that the universe simply continues beyond the reach of our instruments, beyond the reach of our theories, patient and vast, keeping its own counsel. And then there are ideas even more extraordinary, even more difficult to hold. Some physicists and cosmologists have proposed that our universe, the one we live in, the one that contains everything we have ever seen or touched or loved, may itself be just one of an enormous number of universes, a multiverse, each universe perhaps with its own laws, its own constants, its own way of being, some perhaps very similar to ours, some unrecognizably different, some perhaps containing forms of matter and energy that have no name in our physics. This idea cannot currently be tested. There is no observation we can make, no signal we can send or receive that would confirm or deny it. But the mathematics of inflation, the same rapid expansion that shaped our early universe, suggests that our Big Bang may not have been the only one, that other regions of some larger reality may have undergone their own expansions, their own beginnings, their own long cosmic evolutions. We sit here, inside one universe, possibly one of many, unable to see beyond our own horizon, let alone beyond our own existence. And perhaps that is the most honest summary of where we are. Beings of extraordinary curiosity, living inside one bubble of reality, surrounded by horizons we cannot cross, asking questions that the universe does not yet choose to answer. Let that settle, not as something unsettling, but as something freeing. The universe is under no obligation to be small enough for us to understand. And somehow, that is wonderful. Now, from the shape of the universe, let us come back inside our observable home, our sphere of 93 billion light-years, and look at what fills it. For most of human history, we did not know galaxies existed. We looked up and saw stars, nearby stars, our galaxy, the Milky Way, and we thought perhaps that was most of it. Then we discovered that those faint smudges of light, Those cloudy patches in the night sky were not clouds at all. They were entire galaxies, each one containing hundreds of billions of stars, each one a universe unto itself, each one separated from us by distances almost too large to name. And for decades, the best estimate of how many galaxies existed in the observable universe was around 200 billion. 200 billion galaxies, each one with hundreds of billions of stars. That number alone could occupy a mind for a lifetime. But then, more careful studies were done, deeper observations, more patient analysis of the faintest light reaching our telescopes, and the estimate changed dramatically. Newer research suggests the true number of galaxies in the observable universe may be roughly 10 times higher. Not 200 billion, but closer to 2 trillion. 2 trillion galaxies, each one a vast collection of stars. Many of those stars with planets. Many of those planets perhaps with conditions that could support something. Looking up and wondering. 2 trillion galaxies in just the part of the universe we can observe. In just our little window of 93 billion light years. The number is so large, it stops feeling like a number at all. It becomes something more like a feeling, a sensation of impossible scale that washes over you and leaves you very still. 2 trillion. And remember, beyond our horizon, the universe continues, perhaps for an infinite distance, filled perhaps with an infinite number of galaxies, more than any number could describe. We are not in a sparse universe. We are not in an empty universe. We live in something almost unimaginably crowded with structure, with light, with matter, with the raw material of worlds and suns, stretching in every direction, further than we can see, further than we can imagine, further than any number we have words for. And yet, from where you lie right now, the night is quiet. The room is still. The universe, for all its extraordinary fullness, feels peaceful, distant, softly present. 2 trillion galaxies. And here you are, in one of them, on one star's small warm world, in one quiet moment, breathing slowly. The universe is more crowded than we ever thought. And somehow, you have found a still point within it. Let the 2 trillion galaxies exist out there, without needing you to hold them. They have been there for billions of years. They will be there long after tonight. Your only task right now is to rest. Let your thoughts thin out, like light stretched to infrared. Too gentle now to see, only felt. 2 trillion galaxies. An observable universe 93 billion light years wide. A full universe perhaps infinite. A multiverse perhaps beyond even that. And Here, breathing, held at the center of your own quiet horizon, drifting now, at last, towards sleep. The universe is vast beyond all telling, and you are safe within it. Small, and warm, and resting, exactly where you are supposed to be. Sleep now. And so we continue, gently, unhurried. Let your breathing settle even further, each breath a little slower than the last, each exhale carrying something away, some small tension, some lingering thought. We have been resting with an extraordinary number, 2 trillion galaxies, filling our observable universe, each one vast beyond imagining, each one a home to hundreds of billions of stars. And we said, that number was a revision, an update, a correction to what we thought we knew. Tonight, let us sit with that revision a little longer, because it tells us something important, not just about galaxies, but about the nature of discovery itself. For decades, the best minds with the best instruments looked out at the observable universe and counted as carefully as they could, and arrived at a number around 200 billion galaxies. 200 billion. An almost incomprehensible figure. And yet, it turned out to be too low. Not slightly too low. Not off by a small margin. But too low by a factor of 10. How does something like that happen? How do careful, brilliant scientists, with powerful telescopes, miss 90% of the galaxies in the observable universe? The answer is quietly humbling. Most of those galaxies are simply too faint, too distant, too small for our current instruments to detect. They are there, out in the dark, sending their light toward us. But their signal arrives so faint, so stretched, so diminished by the vast distance it has crossed, that our telescopes cannot quite catch it. Roughly 90% of all galaxies in the observable universe remain invisible to us, not because they do not exist, but because we do not yet have eyes sensitive enough to see them. 90%. We have been looking at the universe for centuries, building ever larger telescopes, ever more sensitive detectors, and we have still only glimpsed about 1/10 of what is actually there. The observable universe is more full, more crowded, more alive with structure than our best instruments have yet been able to show us. There is something both humbling and strangely comforting about that. The universe is always more than we think, always deeper, always fuller, always holding something in reserve, waiting for us to build better eyes before it reveals the next layer. And we keep building, and it keeps revealing, and the number keeps growing. Now, those 2 trillion galaxies, were not always spread across the universe as they are today. The early universe was a very different place. In those first billion years, when the cosmos was young and dense and hot, galaxies were not spread out and separated by the vast dark distances we see today. They were closer, more tightly packed, crowded together in a universe that had not yet had time to expand as much as it has now in a given volume of space. In the early universe, there were far more galaxies than you would find in that same volume today. The universe was a busier place, but those early galaxies were very different from the grand spirals and ellipticals we see nearby. They were small, faint, compact, more like what we today call dwarf galaxies. Tiny collections of stars, still finding their shape, still growing, still figuring out what they would eventually become. The universe in its youth was full of these small, faint, delicate things, flickering into existence, gathering their first stars, glowing faintly in the dark of the early cosmos. And then, something began to happen. Something slow and inevitable, and almost tender in its unhurried patience. Gravity. Gravity began to draw these small galaxies toward one another. Slowly, over millions, and then billions of years, they drifted together, approached, and merged. Two small galaxies becoming one larger one, and then that larger one drawing in another, and another, growing, accumulating, building itself up from smaller pieces, like a slow, cosmic gathering, a patient assembly of parts, into something grander. This process of merging, of galaxies combining over cosmic time, is one of the great quiet stories of the universe. The Milky Way, our own galaxy, the one you live inside right now, was not born as the grand spiral it is today. It grew through mergers, through the slow accumulation of smaller galaxies, drawn in by gravity, over billions of years. And it is still growing. Even now, the Milky Way has small satellite galaxies orbiting it, slowly being drawn inward, eventually to merge, to become part of us. We are not a finished thing. We are a work in progress. A galaxy still assembling itself, still gathering, still becoming. And because galaxies merged over time, because small ones combined into larger ones, the total number of separate galaxies in the universe has actually decreased. Since the early days of the cosmos, the universe began with more galaxies, but smaller ones. And over time, those galaxies found each other and became fewer, but grander. It is a kind of cosmic consolidation, the universe trading quantity for scale. Many small things becoming fewer large things. The intimate becoming the immense. And somewhere in those mergers, in those slow collisions of ancient dwarf galaxies. In those billions of years of patient gravitational gathering, the stars were shuffled, and sorted, and arranged, and eventually, around one unremarkable star, in one merged and settled spiral galaxy, a small rocky world formed. And on that world, after another few billion years, life arose. And that life, eventually, looked up and began to count the galaxies. You are the descendant of that counting, of that looking up, of that ancient impulse to understand the darkness above. The galaxies merged so that you could exist. Not purposefully, not by design, but as the long, patient consequence of gravity and time and the slow arithmetic of the cosmos. 2 trillion galaxies today. Many more in the early universe. Most still invisible to our instruments. Each one a chapter in the same long story. A story that began with tiny, faint things, drifting together, finding each other in the dark, becoming something larger than they were alone. There is something in that, worth carrying into sleep. Things finding each other, merging, becoming more than they were. The universe has been doing it for nearly 14 billion years. Let your thoughts merge now. Let the separate worries and questions drift together and settle into something quieter, something unified, something at rest. The early galaxies were small and faint, and they found each other and became grand. And you are here at the end of that long process, small and warm and drifting now toward the quiet. 90% of galaxies still hidden from us. 2 trillion that we know of. Countless more beyond the horizon. And still the universe keeps its secrets. Gracefully. Without effort. Rest now. Let the faint galaxies be faint. Let the distant things be distant. Let the universe be as large as it needs to be. You do not need to hold any of it tonight. Just breathe. And let the dark be full and quiet and kind. And still we drift softly together into the deeper quiet. There is nowhere to be right now. Nothing to do. Nothing to hold. Just this. The gentle unfolding of one idea into the next. Like slow water. Finding its way downhill. Without effort. Without rush. We have been tracing the life of galaxies. How the early universe was dense and crowded. Full of small, faint things that found each other and merged and became the grand structures we see today. And that journey, that long evolution of cosmic structure, turns out to explain something that human beings have wondered about for a very long time. Something so simple, so obvious, that it is easy to forget it was ever a mystery at all. Why is the night sky dark? It seems like it should have an easy answer. The sun goes down. The light fades. And darkness comes. But think about it more carefully. If the universe is infinite, or even just very large, and filled in every direction with stars and galaxies, then wherever you look, your line of sight should eventually hit a star. The way that if you stand in a dense enough forest, no matter which direction you look, your gaze eventually meets a tree trunk. In an infinite universe, full of evenly distributed stars, the entire sky should blaze with light. Every point of the night sky, as bright as the surface of a star. And yet, the night sky is dark. This puzzle has a name. Olber's paradox. Named for a 19th century astronomer who brought it to wider attention, though the question had troubled careful thinkers long before him. And the answer, when it finally came, turned out to be woven into everything we have been talking about tonight. The universe is not infinite in time. It had a beginning. 13.8 billion years ago. Stars have not been burning forever. Galaxies have not existed forever. The universe has not had infinite time to fill every line of sight with light. And the universe is expanding, which stretches the light from distant sources, redshifting it, draining it of energy, pushing much of it out of the visible range, into infrared, into wavelengths our eyes cannot perceive. And in the early universe, before stars formed, there was no light to fill the sky anyway. The darkness of the night sky is not emptiness. It is history. It is the finite age of the universe, written in the absence of light. The dark between the stars is the echo of a time before stars existed, and the dimness of distant galaxies is the universe's expansion, quietly stealing their brightness before it can reach us. The night sky is dark because the universe had a beginning, and because it has been expanding ever since. Two of the most profound facts we know about the cosmos, written in the simple darkness above your head every night. Now, let us go deeper still into what the universe actually shows us. When we look beyond the narrow slice of light our eyes were built to see, human vision is remarkable, but it occupies only a tiny sliver of the full spectrum of light that exists. We see what we call visible light, the colors of the rainbow, red through violet, a narrow band in a spectrum that extends almost infinitely in both directions. Below red lies infrared, then microwaves, then radio waves, stretching to wavelengths longer than buildings. Above violet lies ultraviolet, then X-rays, then gamma rays, with wavelengths smaller than atoms. All of it is light. All of it is the same fundamental phenomenon. Electromagnetic radiation, traveling at the same extraordinary speed. carrying information about its source. But our eyes see almost none of it. And the universe does not restrict itself to what our eyes can detect. Objects that are completely invisible in ordinary light blaze with brilliance in other wavelengths. A galaxy hidden behind clouds of dust, invisible to an ordinary telescope, may shine clearly and brightly in infrared light, which passes through dust the way sunlight passes through glass. A cloud of gas between the stars, invisible and dark invisible light, may glow intensely in radio waves or in X-rays, broadcasting its presence to instruments tuned to receive it. Some of the most dramatic objects in the universe, black holes drawing in surrounding matter, neutron stars spinning hundreds of times per second, the remnants of ancient supernova explosions, are nearly invisible in ordinary light, but extraordinary, almost overwhelming, in X-rays or gamma rays, in the cosmic microwave background itself. That ancient first light we have spoken of so often tonight is completely invisible to human eyes. We cannot see it. We cannot feel it. We pass through it every moment of our lives, without any sensation, without any awareness. And yet it is there, everywhere, detectable only with instruments designed to see what our eyes cannot. Astronomers have built telescopes for every wavelength. Radio telescopes with dishes as wide as football fields, spread across entire continents, working together as a single instrument. Infrared observatories, some floating in space, above the blurring warmth of Earth's atmosphere, looking back toward the earliest galaxies. X-ray telescopes in orbit, mapping the hottest, most violent regions of the cosmos. Each wavelength, a different language, in which the universe tells a different part of its story. And when astronomers look at the edge of the observable universe, across all these wavelengths, they find things they would never have found using visible light alone. Galaxies that vanish in one wavelength reappear in another, as if the universe has multiple layers, multiple faces, each one visible only from a certain angle, in a certain kind of light. The universe we see with our eyes is only one layer, one face, and beneath it, around it, threaded through it, is a universe we are only beginning to understand. Because here is something that takes a moment to truly absorb: the stars, the galaxies, everything we have been talking about tonight, all the light, all the structure, all the 2 trillion galaxies, all the ancient mergers, all the redshifted whispers from the edge of the observable universe. All of that is only a small fraction of what actually exists. Visible matter, the stuff that glows, that emits or reflects light, that our telescopes can detect in any wavelength, makes up only about 5% of the total content of the universe. 5%. The remaining 95% is made of things we cannot directly see, cannot directly detect, cannot yet fully explain. About 27% is something called dark matter, a substance that has mass, that exerts gravity, that shapes the large-scale structure of the universe, holding galaxies together and guiding the formation of cosmic structure. But that emits no light, no radiation of any kind. That passes through ordinary matter, almost as if it were not there. We know it exists because we can see its gravitational effects. Galaxies rotating in ways that only make sense if there is far more mass present than we can see. Light bending around regions of space where no visible matter exists to bend it. Something is there. Something massive. Something everywhere. And we have no idea what it is. And then there is the remaining 68%. Something even stranger. Something called dark energy. A property of space itself that is causing the expansion of the universe to accelerate, to speed up, to push galaxies apart, faster and faster. With every passing moment, we do not know what dark energy is. We do not know where it comes from. We do not understand it at all. We just know it is there, because the universe is expanding in ways that visible matter and dark matter alone cannot explain. 5% visible, 27% dark matter, 68% dark energy. The universe that dazzled us, with its 2 trillion galaxies, and its ancient light, and its cosmic microwave background, and its extraordinary size and age. That entire universe is only 5% of what exists. 95% of reality is hidden from us, not beyond the horizon, not in some distant unreachable region, but here, everywhere, threaded through everything, present in this room, in the space between your hands, in the air you are breathing, invisible, unknown, vast. We live inside a universe that is mostly hidden from us, and we are only beginning to learn the language needed to find it. Let that rest in your mind, not as something troubling, but as something wonderful. There is so much more, so much still waiting to be understood, so many layers still to be uncovered, so many faces of the universe not yet seen. The night sky is dark because the universe had a beginning. The universe speaks in wavelengths we cannot see. And 95% of everything is hidden in plain sight. You are resting inside a mystery, the grandest mystery there is. And it holds you gently, without asking anything of you. Let your eyes grow heavy. Let the dark matter pass through you, as it always has, as it always will, without you feeling a thing. Let the dark energy do its quiet work, expanding the universe a little larger with every breath you take. And let yourself, at last, grow still. The hidden universe surrounds you. The visible universe stretches in every direction. The ancient light is traveling. The galaxies are drifting. And you are resting in the 5%. The luminous, the brief, the beautiful 5% that shines. Sleep now. You are held by forces you cannot see, in a universe you cannot fully know. And that is perfectly, completely all right. Rest. And so we arrive, slowly, gently, at something like a resting place. Not an ending. The universe does not do endings, but a place to pause, to breathe, to let everything we have explored tonight settle like snow, softly, without urgency, into the quiet places of the mind. We have traveled far together. We began with a simple question: where does the universe end? And we found that the question itself was more beautiful than any simple answer could be. We learned that the edge is not a wall, but a horizon, a limit set by time and light, not by any barrier placed there by the universe. We learn that the observable universe spans 93 billion light years, that it is filled with 2 trillion galaxies, that most of them are still too faint for us to see, that 95% of everything that exists is hidden from our instruments. We learn that space itself expands, that ancient light arrives stretched and reddened, that the cosmic microwave background is the oldest signal we can receive, a whisper from 380,000 years after the beginning. We learn that galaxies merged over cosmic time, that the night sky is dark because the universe had a beginning, that dark matter and dark energy fill the cosmos, unseen, unfelt, and not yet understood. And now, in this final gentle stretch of our journey, we arrive at perhaps the most honest thing we can say. Much of the universe is still inferred, rather than directly observed. We have not seen most of it. We have reasoned toward it. We have followed the mathematics, and the physics, and the patterns, and arrived at conclusions that feel solid. And yet, so much remains beyond the reach of any instrument, any wavelength, any signal we know how to detect. The observable universe, for all its extraordinary size, for all its 2 trillion galaxies, and its ancient light, and its vast dark matter scaffolding, is only a tiny fraction of the total cosmic story. A small chapter in a book whose length we cannot determine. And the horizon itself, that boundary we have been circling all night, is not only a limit for light. There are other messengers, other ways the universe speaks. Neutrinos, tiny, almost massless particles that pass through ordinary matter as if it were not there, racing through the cosmos at nearly the speed of light, carrying information from the earliest moments of the universe, from times even before the cosmic microwave background, when the universe was only a few seconds old. We can detect these ancient neutrinos in principle, though they are extraordinarily difficult to catch. And they bring their own horizon with them, their own limit on how far back they can show us. And then there are gravitational waves, ripples in the fabric of space itself, generated by the most violent events in the cosmos. Colliding black holes, merging neutron stars, the death throes of massive suns. These ripples travel through space, compressing and stretching it as they pass, and we have learned to detect them only very recently, with instruments of extraordinary sensitivity. Gravitational waves carry their own information, their own view of the universe, their own horizon, potentially reaching back even further than light can show us. Each messenger, each wavelength, each particle, each ripple in space brings its own window, its own limit, its own edge beyond which it cannot show us. And yet, beyond all these horizons, beyond the furthest reach of light, beyond the oldest neutrino, beyond the most ancient gravitational wave, the universe does not stop. Space may continue forever. There may be galaxies out there, right now, existing, turning slowly, their stars burning, their worlds orbiting, their ancient light traveling toward us, but traveling through a space that is expanding too fast for that light to ever arrive, permanently beyond our reach. Not because they are destroyed, not because the universe ends there, but because the horizon lies between us, and will never move enough to let them through. Entire regions of reality, causally disconnected from us forever. No telescope will ever show them to us. No matter how powerful, no matter how patient, no matter how many generations of scientists turn their instruments toward the dark, if parts of the cosmos are permanently beyond our causal reach, then they are permanently beyond our knowledge. Not just for now, but forever. And there is something in that. Something worth sitting with. In the quiet before sleep. We are beings of extraordinary curiosity. We have built telescopes that see to the edge of what is visible. We have detected gravitational waves from black holes a billion light years away. We have mapped the cosmic microwave background to a precision of millionths of a degree. We have done things that would seem like magic to every human who lived before us. And still, the universe holds more than we can reach, more than we can know, more than we can even meaningfully ask questions about. The observable universe is not the whole universe. It is only the part that cosmic history has allowed us to see. Our window, our chapter, our small, luminous, temporary view into something immeasurably greater. And perhaps this is the most truthful thing we can say about the edge of the universe. The edge is not really a place in space. It is the edge of human knowledge itself. It is the place where our questions run out of answers, where our instruments run out of signal, where our mathematics runs out of things to describe, and where the universe simply continues beyond the reach of anything we have or may ever have. The edge of the universe is the horizon of what we are capable of knowing. And that horizon, like all horizons, is not a wall, not a failure, not a defeat. It is an invitation to keep looking, to build better instruments, to ask better questions, to follow the light wherever it leads, and to hold the rest, the vast, the permanent unknown, with humility and wonder and a kind of peaceful acceptance. We will never know everything, and the universe does not ask us to. It simply asks us to look, for as long as we are here, with whatever eyes we have, and then to rest. So let that be enough for tonight. Let the inferred universe be inferred. Let the unseen remain unseen. Let the permanently unreachable remain out there in the dark, existing without us, needing nothing from us. We have looked tonight, as far as light can carry us, as far as thought can reach, across 13.8 billion years of cosmic history, across 93 billion light-years of observable space, through 2 trillion galaxies, through dark matter and dark energy, through the first light and the last horizon. And now, it is time to rest. The edge of the universe is the edge of what we know, and the edge of what we know is where wonder begins. And wonder is a very good thing to carry with you into sleep. So close your eyes, if they are not already closed. Let the observable universe exist, just as it is, vast, patient, mostly hidden, entirely indifferent to whether we are awake or asleep. Let the horizon be where it is. Let the dark matter flow through you. Let the dark energy do its quiet work. Let the ancient light travel. And let yourself, at last, fully, completely, rest. You have traveled to the edge of the universe tonight, and found that the edge is not an ending. It is simply where the known meets the unknown, and the unknown is vast, and dark, and full, and quietly, extraordinarily beautiful. Sleep now. The universe will still be there. When you wake, larger than you can imagine, older than you can hold, and somehow, still, yours to wonder at. Good night.